What's the answer? Come on. Quickly solve it. What's the answer? ఏమిటి
11.5, ma'am.
ఎంత
11.5.
correct 11.5 is the right answer అయిపోవాలి తొందరగా so this will be how many kgs 0.9 kgs this will be how many kgs hydrogen
0.035.
ఏమిటి ఒక్కళ్ళే చెప్తున్నారు అసలు ఎవరు మీరు సిద్ధపోతున్నారా how about this 0.03 is oxygen what's the formula used 100 by 23 into 32 by 12 into 0.9 plus 8H minus O. 8H minus O will be going to be 8 into 0.035 minus 0.03. That will be equal to 100 by 23 into what's 32 by 12 into 0.9 equal to
2.4.
2.4 plus 8 into 0.035
2.28.
0.28 minus 0.03 that will be equal to how much
0.25.
0.03 ఎంత
0.25, ma'am.
0.25 okay that will be equal to 100 by 23 into 2.65 equal to 11.5 kgs of air is required. This is one pattern of question. Okay, we have seen only without percentage one pattern. Okay, there we solve that of pure carbon and methane. Then the next is calculation by weight, giving the percentage of individual components. This is also many a times asked. The next one is the 4 patterns you need to identify. Okay, the 5th question is take down the 5th question. A gas used in internal combustion engine. A gas used in internal combustion engine had the following composition by volume. Had the following composition by volume. Hydrogen 45%. Hydrogen composition by volume. Okay, hydrogen 45%. Methane CH4. Methane 36%. methane 36%. See, the sum total should be 100. Okay. If by chance oxygen is not given, then you can consider it either as 0 or you can minus 100 minus. Okay. That's the generally used idea. You can make it 0 or sometimes 100 minus you can calculate. Okay. Next. Carbon monoxide 15%. Carbon monoxide 15%. Nitrogen N2 is 4%. N2 is 4%. Find the volume of air required for the complete combustion. Find the volume of air required. Find the volume of air required for complete combustion of 1 meter cube of gas. 1 meter cube of the gas. Now you don't use this formula. 100 by 23 is not applicable. Here air 121, but you can't substitute. Okay, you need to solve it little. It's a very little differently. Okay. Now to solve this numerical, again we have to get the volumes. Okay. So volume of H2 will be how much? 0.45 meter. Volume of H2 will be 45% means 0.45 meter. Volume of methane will be equal to 0.36 meter. Carbon monoxide is 0.15 meter. What we can convert nitrogen, but nitrogen is a benign element. It neither supports combustion nor decreases the calorific value. So you can ignore. We don't bother about the oxidation of nitrogen at all for any practical application. Okay. Next, let me go ahead with the calculation. So the volume of oxygen is what we require, followed by the volume of air. So first let me calculate the volume of oxygen required. So again I have to write the balanced equation. Okay, for the first one, hydrogen. Volume of O2 required for complete combustion of hydrogen. Okay, H2 reacts with half O2 to form H2. Okay, least possible combination or even the ratio. Okay, that means 1 mole requires 0.5 moles or 1 meter cube of air. Hydrogen gas requires 0.5 meter cubes of oxygen for complete oxidation. So I understood that 1 meter cube of H2 requires 0.5 meter cube of oxygen. In the fuel, I have 0.45 meter cube of hydrogen. It requires how much amount of oxygen? Okay, so for 0.45 meter cube of hydrogen, I require 0.45 into 0.5. Enter. 0.45. Don't ready? 0.225 meter cube of O2 is required. Okay, meter cube of O2 is required. I'm just calculating the volume of oxygen required individually. Okay. Next, for methane, I'm just moving the board. For methane, what I should write? Second one, volume of O2. For methane is, I'll get back to the chemical form. CH4 reacts with oxygen to form CO2 and H2 as the products. Okay? But the equation is not balanced. Balance the equation first. For stoichiometry. Okay? Carbon, hydrogen 4, so 2 out here. 4 oxygens, 2. Okay? For knowing the stoichiometry, we have balanced. Okay? Now what we can get from this? 1 meter cube of methane requires 2 meter cubes of oxygen. Easy. Next, 0.36 meter cubes of methane requires how much? 0.36 into 2. That is equal to 0.72 meter cubes of oxygen. Okay. 0.72 meter cubes of O2 is required for complete combustion of 0.36 meter cubes of methane. Okay. Now we'll keep this as the other one. What we are targeting is getting the net sum of oxygen required for complete combustion of that particular fuel. Is it not? We have gone into the individual combustion. Okay, methane, hydrogen, then followed by carbon monoxide. Okay, carbon monoxide oxidation requires what? Volume of O2 required for carbon monoxide. I write the balanced equation for stoichiometry. CO reacts with O2 to form CO2. Not balanced. 2, 4, 2 here. Okay. So what is the stoichiometry? 2:1. 2 carbon monoxides require 1, or 1 meter cube of carbon monoxide requires 0.5 meter cubes of O2. Okay. In the fuel, we have 0.15 meter cube of carbon monoxide. Okay. So it requires how much amount of oxygen? 0.15 into 0.5. That will be equal to 0.15 into 0.5. 0.075 meter. 0.075 meter cubes of O2. And I told you, nitrogen does not require any oxygen. We will not consider. Even if it requires, we don't break our head at all. Because it does not support combustion nor calorific value. It is neutral element. Now can I write the total amount of oxygen required? Okay. So what's the next one? Total amount of oxygen required. Total amount of O2 required is equal to 0.75 plus 0.72 plus 0.221. That will be equal to 0.75 plus 0.075. Huh? Wait, this is 0.075 kids. Come on. 0.075. 0.075 plus 0.075 plus 0.225 is equal to 1.02 meter cubes of O2. Okay. Amount of air required by volume is equal to amount of air required by volume equal to one point zero two into 100 divided by 21. Enter. Four 4.857. 4.857 meter cubes of air is the answer. Take down the number. Most welcome. Huh? You can join the class if you want. Like, okay. Now let me give you one numerical for your exercise. Calculate the amount of air required. Calculate the amount of air required for complete oxidation. Amount of air required by volume. By volume. For complete oxidation of. For complete oxidation of 1 meter cube of gas containing 1 meter cube of gas containing CH4 3.5%, CH4 3.5%, 3.5%, sorry, 3.5%. Carbon monoxide 25%. Carbon monoxide 25%. H2 10%. H2 10%. Carbon dioxide 10.8%. N2 50.7%. CH4 3.5%. Carbon monoxide 25%. Hydrogen 10%. Carbon dioxide 10.8%. Nitrogen is 50.7%. Calculate the volume of air required for this complete combustion of this gas in volume, by volume. Okay, what's the answer? అయ్య బాబాయ్ అయిపోతుంది టైం. నేను ఎప్పుడు చెప్పాలి మళ్ళా ఫ్లో చార్ట్ ఫర్ కాంపోజిట్స్? Is it over? Hello? Anyone in the class? ఏంటి రెస్ట్
Yes, ma'am.
తీసుకున్నారు? ఎస్ ఏంటి? ఏమిటి నీరజ్? ఎస్ ఏంటి? వాట్ ఈస్ ద ఆన్సర్? వాట్ ఈస్ ద ఆన్సర్? రాలేదా మీకు ఆన్సర్? అయ్యో కంపల్సరీ క్వశ్చన్స్ బాబోయ్. Will you consider the amount of oxygen for carbon dioxide N2? No. You'll stop at methane, carbon monoxide and hydrogen. Okay? Now calculate the answers quickly. You're not following? సరిగ్గా చెప్పట్లేదా? నువ్వు సరిగ్గా వినట్లేదా మీరు? What's the answer for methane? This is how many meter cube? 0.035 meter cube as usual. This is how much meter cube? 0.25 meter cube. This is how much? 0.10 meter cube. I'll not consider for carbon dioxide and N2. Now do the calculation as per the stoichiometry. Okay, for 1 meter cube of methane, it requires how many meter cubes of oxygen? What's the stoichiometry? Hello? Is anyone there in the class or not? Akshaya, good afternoon. Akshaya, you're there?
Ma'am, answer 1.16, ma'am.
కాదు, దీనికి చెప్పండి. అక్షయ ఏం చేస్తున్నావు? ఆన్ చేసి వెళ్ళిపోయిందా మైక్? శ్రీజ?
Yes, ma'am.
స్టాయికియోమెట్రీ ఏముంది? మీథేన్ కంప్లీట్ ఆక్సిడేషన్ కి ఎన్ని 1 mole of methane requires how many moles of oxygen for complete combustion?
2 moles, ma'am.
2 moles. సరే, so 0.35 moles of methane requires how much amount of oxygen?
0.07 meter cube.
ఎంత? 0.07.
07.
Correct. Good. Next. Somesh. Hello. ఏంటి ఆన్ చేసి వెళ్ళిపోతున్నారేంటి? Stupid kids. It's as if just log out, no problem. What's the point being present in the class like this? What roll number 68, Shivaji? ఇదేంటి లైన్ కట్టారు? సాయి?
Yes, ma'am.
Good afternoon. So
Good afternoon.
what's the amount of oxygen required for complete combustion of carbon monoxide? 25%. What's the stoichiometry?
మ్యామ్ నేను ఆ క్వశ్చన్ కాపీ చేయలే మ్యామ్, ముందు క్వశ్చన్ చేసిన మ్యామ్. నేను అంటే ముందు క్వశ్చన్ చేస్తుంటే మీరు ఆ క్వశ్చన్ డిక్టేట్ చేసేసారు.
కార్బన్ మోనాక్సైడ్ సిల్లీ ఆన్సర్స్ ఇవ్వకండి నాకు. Carbon monoxide requires 0.5 carbon dioxide. So 1 mole requires 0.5 moles, or 1 meter cube requires 0.5 meter cubes. So 0.25 meter cubes of carbon monoxide requires how much? ఎంత? వన్ మ్యాన్ షోలా ఉంది. ఎందుకు రైట్ హర్షిత?
0.125, ma'am. 125.
125. Madam has got scared seeing at our performance levels. Okay.
మ్యామ్ ఫస్ట్ వన్ మీథైన్ 3.5% అయితే 0.035 వస్తుంది కదా మ్యామ్.
0.035 into 2 ఎంత ఆన్సర్?
0.070.
కార్బన్ మోనాక్సైడ్ కి
0.125.
2.5 ఎంత?
0.125 మ్యామ్.
0.125 మీటర్ క్యూబ్. 0.125 మీటర్ క్యూబ్. నెక్స్ట్ హైడ్రోజన్ కి
0.05.
అండ్ ఎలా వచ్చింది? 1 మోల్ కి 0.5 మోల్స్. సో 0.5 మోల్స్ కి ఎంత?
0.05 మ్యామ్.
0.05 ఏంటి? 0.5 into 0.5 ఎంత?
1 మోల్ కి 0.5, 0.1 మోల్ కి కదా మ్యామ్.
0.1 మోల్ కా? ఓకే. 0.1 మోల్ కి ఎంత? 0.1 into
0.05. 0.05.
0.05
Yes
meter.
ma'am.
Okay. So total amount of oxygen required ఎంత?
0.245.
Huh?
0.245 మ్యామ్.
0.245 ఎంత? 0.07 plus 0.125 plus 0.05 meter cubes కి ఎంత?
0.245 మ్యామ్.
0.245. Sorry, meter cube of oxygen is required. Okay. How to convert it into amount of air?
0.245 into 100 by 21.
Everyone, please hold on. Meet Geeta madam. Let's. Okay. So, how to calculate amount of air required by volume into 100 by 21? Kada? Okay. So, 100 by 21 into 0.245 enta?
1.16.
1.16 meter cube. Now, if I ask the answer in weight, what you are going to do? Thanks. And the answer is 1.167 meter cube. So it's by volume. By weight ఎలా? ఏం సుమిత్ ఉన్నావా క్లాస్ లో?
Yes, ma'am.
Okay. How to do it? Get back to the formula. What? 28.94 grams or 28.94 grams occupies 22.4 liters. Okay. Or I can say that 28.94 into 10 power minus 3 kgs. Okay. Then do the calculation. Considering the molecular weight of the air. What's the answer? .167 into 28.9 divided by 22.4 ఎంత? What's the answer? Into 28.9 divided by 22.4. That will be the weight. Okay. Enta, what's the answer?
One point five.
1.49.
1.49
9.
49 kgs of air is required by weight. Okay. Now I'm going to discuss the last numerical. I will conclude the class after this. Very, very important. Excess of air. Sought after numerical in this. Okay. Now, if excess of air is supplied, then how to calculate the air quantities? Okay. Take down this numerical. Okay. A gaseous fuel has the following composition by volume. A gaseous fuel has following composition by volume. See, this is the fourth type of numerical I am giving you. Okati only by weight, okati only by volume, okati calculating weight and volume, giving percentages. Okay. Now this is by volume taking excess of air. Okay. So numerical. Emma, Sai, Rastunawa, serious ka?
Yes, ma'am.
Is important numerical. Under class law. Okay. Because you have taken all the interest to listen to the class, you should also take that interest to understand the important numericals. Okay. Your mid will go, but your finals will dictate your percentage score. That's important, and it is offline pretty much. Okay. I'll get that. A gaseous fuel has following composition by volume. Hydrogen 22%. H2 is 22%. Okay. Methane 4%. Okay. Carbon monoxide 22%. Carbon monoxide 22%. Carbon dioxide 6%. Carbon dioxide 6%. N2 45%. Nitrogen 45%. Okay. If 20% excess of air is used, if 22% excess of air is used, find the volume of air actually supplied. Find the volume of air actually supplied for complete oxidation of the gas. For complete oxidation of the gas. Okay. For this numerical also, need not have to consider the oxidation of carbon dioxide and nitrogen. Leave it. Now do the calculations for this. Okay. How much this is equal to 0.22 meter cube of H2 and calculate the amount of oxygen. For this, calculate 0.04 meter cube. Okay, for this again 0.22 meter cube, calculate the amount of oxygen required. Okay, just calculate the total amount of air. I'll get back in a minute. What is this? Class is not over yet. Okay, we will finish in another 5 minutes time. Okay. Now we will start giving me the answers. And we solve the numerator. Okay. So I'll start writing the answers. Please tell me and we'll conclude. So 0.22 meter cube. Okay. So 0.22 meter cube into 0.5 will be equal to how much?
0.11. 0.11, ma'am.
0.11 meter cube of O2. Okay. For complete oxidation of methane, it will be into 2. That will be equal to
0.08.
0.08 meter cube of O2. Next, into 0.5 for carbon monoxide. And again it will be 0.11 meter cube of O2. So the total volume of oxygen required is
0.3.
0.3.
0.3. Okay. So 0.3 meter cube of O2 is required. And because excess of air is given in this numerical, how to start writing the calculation? Minimum amount of air, that is exact amount of air required for supplying 0.3 meter cube of O2 for 0.3 meter cube of O2 supplied is equal to 0.3 into 100 by 21. Enta
1.42.
1.42 meter cube of air is required. Okay. Now after this, what we are going to do is, because 20% excess, and the 20% ichana, 20%
22.
excess of air is to be supplied. Okay. Right. The excess volume of air is the board eligible. Okay. The excess volume of 20% air is given by
22%, ma'am.
20,
2%.
22% excess, huh?
Yes, ma'am.
22%. అంటే ఎంత 1.42 into 22 divided by 100. ఎంత అంత. That's the answer. 1.42 into 22 divided by 100 is going to be the answer. How much? You not calculate.
0.312.
0.31, huh?
312.
312.
0.312 0.312 meter cube of air. Okay. So 0.142 plus 0.312 will be the net answer for the numerical. Okay. Enta. Okay. Now this concludes the chapter fuels. I'll give one numerical, please solve it, and I'll give you the answer. Now we should conclude. Fine. Answer this numerical and let me give this and this concludes the chapter. I asked the question for the numerical. Calculate the minimum amount of O2 required by weight and volume For complete combustion of 1 kg of coal. For complete combustion of 1 kg of coal. If 40% excess of air is supplied, 40% excess of air is supplied. Okay. Carbon 75%. Carbon 75%. Hydrogen 5.2%. Hydrogen 5.2%. Oxygen 12.1%. Nitrogen 3.2%. Ash 4.5%. Ash 4.5%. Okay. Shall I repeat the question? Give the answer by weight and by volume. Okay. 1 kg of coal, I need the amount of oxygen required, and also calculation of amount of oxygen by weight and volume if 40% excess is supplied. Okay. Here there's one more question. Also calculate HCV and LCV using Dulong's formula. That is the massive question. Also calculate HCV and LCV using Dulong's formula. Okay. Tomorrow, just in the morning by 10:30, I'll start with composites, introduction and flow charts, followed by a brief discussion on green chemistry. After 3 PPTs being explained exclusively, not a single point left actually. If I would give a lecture, that would have less number of content as compared to the PPTs that have described elaborately about the green chemistry. So I'm expecting tomorrow by 12:30, I'm going to finish chemistry syllabus. Join by 10:30 sharp, will conclude by 12:30 tomorrow evening. Okay. And so your attendance and